In this epidemic simulation, we're using faked social media data that relates people and organisations to give us a realistic social network graph, contact graph. Within that graph, we have seeded a single individual as patient 0. We can now initialize the simulation, and we will use the property infection to denote whether an individual is infected or not infected. We play the simulation using some sort of default values for duration of the infectiousness, probability of passing on to your neighbours, and the iteration rate of the simulation. As you can see, new cases occur from the original patient 0. Let's pause the simulation and have a look and see how the infection is doing. We can see that it has just started to infect this large cluster in the center of the diagram. Now let's continue. As the large cluster gets completely infected, cases explode and we go geometric. This spreads cases throughout the social graph. And interestingly enough, our case increase rate sort of goes back to linear. I think as we're reaching a kind of limits on our population. As you can see, our new cases is actually getting quite low now, so we're reaching the end of this epidemic. However, there is a final cluster of previously uninfected individuals on the left, the far left of the cluster. And you can see that the infection is gradually burning through that subset of the social graph. When the infection has completely burnt itself out, your results are downloaded.